Articulator, a mechanical instrument that represents the temporomandibular joints and jaws, to which maxillary and mandibular casts may be attached to simulate some or all mandibular movements. Classification of articulators. Michigan University classification. Class I. A Class I instrument is a simple holding instrument which is capable of accepting a single static relationship. In these articulators vertical motion is possible, but only for convenience. Class II. These are instruments that permit horizontal as well as vertical motion but do not orient the motion to TMJ via Facebook transfer. Class IIA. In Class II Type A, eccentric motion permitted is based on average or arbitrary values. Examples of this type of articulators are the Gissi simplex articulator, Gridman. Class IIB. In Class II, Type B, an eccentric motion permitted is based on theories of arbitrary motion. Examples of these classification of articulators are Monson maxillomandibular articulator. In Class II Type C, an eccentric motion permitted is determined by the patient using engraving methods. Examples of these articulators are Howarth articulator, dentograph. Class III. These are instruments that simulate condylar pathways using average or mechanical equivalence for all or part of the motion. These instruments allows joint orientation of the cats via Facebook transfer. Examples of these instruments are Hanomet. Class III, Type A are instruments that accept a static protrusive registration and use equivalence for the rest of motion. Examples are Hanau Model H, Dentidus Bergstrom. Class III, Type B are instruments that accept static lateral, protrusive registrations and use equivalence for the rest of motion. Examples are Trubite articulator, Ney, kinescope, Hanau 130-21, Panadent and Stansberry tripod. Class IV are instruments that will accept three-dimensional dynamic registrations. These articulators allow for joint orientation of casts via Facebook transfer. Class IV, Type A are the cams representing the condylar paths are formed by registrations engraved by the patient. Examples of these instruments are TMJ articulator. Class IV, Type B are instruments that have condylar paths that can be angled and customized either by selection from a variety of curvatures or by modification or both. Examples of these articulators are DENAR D4A, DENAR 5A, current and simulator. Requirements of articulators. Minimal articulator requirements. These minimal articulator requirements are necessary for the fabrication of complete denture to the patient's centric position. This position must be accurately refined for both monoplane or cuspless occlusion and cusp occlusion. 1. The articulator must accurately maintain the correct horizontal and vertical relationship of the patient's casts. In other words, the articulator must accurately maintain centric position. 2. The patient's casts must be easily removable and attachable to the articulator without losing their correct horizontal and vertical relationship. This is desirable for many laboratory procedures. 3. The articulator should have an incisal guide pin with a positive stop. THAT is adjustable and calibrated. This provides positive control over the patient's occlusal vertical dimension by the dentist and laboratory technician. 4. The articulator should be able to open and close in a hinge-like fashion. 5. The articulator should accept a Facebook transfer utilizing an anterior reference point. The Facebook transfer relates the maxillary cast to the horizontal axis of the articulator in the same manner THAT the patient's maxilla relates to the opening axis of the temporomandibular joints. This allows minor changes in the patient's vertical dimension without grossly changing the patient's occlusion at the centric position. Also, the anterior reference point transfer facilitates the arrangement of the anterior teeth to the desired labiolingual inclination. 6. The construction should be accurate, rigid, and of a non-corrosive material. The moving parts should resist wear. The adjustments should be able to move freely and be definitely secured. 7. The design should be such that there is adequate distance between the upper and lower members and that vision is not obscured from the rear. The articulator should be stable on the laboratory bench and not too bulky and heavy. Hanau articulators. Rudolf L. Hanau, an engineer, believed that the Hall and Monson theories were misinterpretations of masticatory movements as applied to articulators and believed that it was absolutely necessary to adjust an articulator to comply with given individual requirements. The Hanau articulators were popular with dental professionals for their ease of use and durability. Hanau in 1921 developed a research model called the Hanau Model C articulator. One later in 1923, he devised the kinescope 1, which he claimed to provide exact measurement of mandibular movements. HANA Model H110, 1926, evolved from Model H115 in 1926. The HANA Model H110 incorporated individual condylar guidance adjustments in both the sagittal and horizontal planes. Rather than using lateral positional records, the lateral setting was calculated by dividing the condylar inclination by 8 and adding 12.1 L equals H/8 plus 12. HANA Model H110 modified 1927. Similar to H110 except that it had an incisal guide table instead of incisal guide cup. 1. HANA Model H2 Series 1958. It was a non-Arcon, semi-adjustable articulator. Principal feature was an increased distance between upper and lower members from 95 mm to 110 mm. It had a fixed intercondylar distance of 110 mm and accepted face-bow transfer. Horizontal condylar inclinations were simulated by means of a protrusive interocclusal record. Bennett movement was calculated from horizontal condylar inclinations by the formula L equals H/8 plus 12. The mechanical incisal guide table was adjustable both in sagittal and frontal planes. HANA Wide View Models 183 and 184, the HANA Wide View EI and HANA Wide View E2 are the newest articulators. They are Arcon with fixed intercondylar distance of 110 mm. The difference is that HANA Wide View EI has a closed condylar track and HANA Wide View E2 has an open condylar track which allows upper member to be removed. Wide View E2 has condylar retainers to avoid accidental separation of upper member. A micrometer protrusive, retrusive condylar adjustment is available which is accurate to 0.05 to the power of 2. Horizontal condylar angle is adjustable from -20 degrees to 60 degrees and side shift angle adjustment is from 0 to 30 degrees, same as H2. The straight incisal guide pin or with adjustable foot is available. The straight pin has dual ends, chisel and spherical which extends above the upper member to act as a third point stability when inverting the articulator for mandibular cast mounting. 3 incisal guide tables are available, mechanical, flat and pantacrylictable. Virtual articulators. Virtual articulators are also called as software articulators. They are not concrete but exist only as a computer program. They comprises of virtual condylar and incisal guide planes. Guide planes can be measured precisely using jaw motion analyzer or average values are set in the program like average value articulator. The virtual articulators are able to design prostheses kinematically. They are capable of simulating human mandibular movements, by moving digitalized occlusal surfaces against each other and enabling correction of digitalized occlusal surfaces to produce smooth and collision-free movements. Programming of virtual articulators. Prerequisite for visualization on screen is 3D scanning, digitizing of tooth surface or restorations or denture models using 3D scanner. There are 2 types of digitization. A. Direct digitizing in which tooth surfaces are scanned inside patient's mouth. B. Indirect digitizing in which tooth surfaces are scanned in the cast obtained from pouring the impression of the patient. Advantages and uses. Visualization of contact points dynamically during jaw movement. The clinician can visualize the teeth surface occlusion for contact points and prematurities leading to proper information for the diagnosis. Drawbacks. A record has to be made for each patient, which is certainly not practicable for every clinician. Conclusion. The history of the development of articulators is filled with many interesting theories and conflicting concepts. In the last 2 or 3 decades, there have been concurrent tendencies either to reduce the articulator to a simple hinge or to make them more and more complex so that to record all mandibular movements. The success or failure of the final restoration is more dependent on the operator of the articulator than on the articulator itself. In other words, a semi-adjustable articulator in the hands of a knowledgeable clinician may be of greater assistance in treatment than may a fully adjustable articulator in the hands of an inexperienced operator.